Quacks. Today we're going to be talking about Mindstorms' new programming language, Mindstorms Home, specifically more advanced features and how to do them. If you haven't seen my previous video, which is the bare basics of Mindstorms Home, I'd highly recommend you check it out. I'll put it up in the corner. So our topics for today, let's go ahead and dive right in. We're going to be replicating advanced features from Ev3G into Mindstorms Home, and then we're going to convert an Ev3G program to a Mindstorms Home program. So in Ev3G, there's my blocks, and when you make a my block, you have a whole bunch of options. So you can make inputs and outputs. Pretty easily. You just go and make it an output. And then once you've done that, you can use them as inputs and outputs. And it works like a champ. Now, in Ev3 Home, on the other hand, when you go to make a my block, you don't have those options. Your options are number, or text, or Boolean. And you can also add a label if you so choose. Now, there's a couple problems here. First of all, you can't rearrange them. So if you decide you don't like them, you have to delete them and then add it back to rearrange it, which is kind of a pain. Another problem here is if you try and add another label for your first parameter after the myblock name, it just merges. So you have to do something like myblock name and then dash and then the first variable name. And the biggest problem, there's no outputs. So if you're trying to make a my block that can output something, so let's say you're trying to make a range checker, you're trying to make a centimeters to wheel rotations converter, you're trying to make, most my blocks need to output something. So in order to do this, we're going to replicate this exact thing. So all it does is this Ev3G program takes a input and then just outputs it exactly, which is not the most useful, but it shows how to make this work. So we're going to start and we're going to call it the replicator. We're going to add an input we call A. And so then we're going to have to add, and I'm going to delete these that I had from earlier. We're going to have to make a variable that's called, and you should follow convention, something like replicator output. So then what we do is like that. So then we could say something like, and then later on, or more useful, and see how this is true, because it goes and runs replicator with this and then plugs it in there. If I put, so that's how you do it. Also, deleting my block, just drag the define statement in there. Poof, my block's gone. Okay, multi-threading. So in Ev3G, this is pretty easy. You just seed this wire. You want to do something at the same time, grab another one, drag it, plug it in. Ev3 Home, it's about as easy. You add another, when event starts, you add another when blank. Now the problem is, in Ev3G, you can branch off from anywhere. Ev3 Home, the only way to branch off like that is to say when, and then we're just going to use replicator output here so I don't have to make another one. So we're going to make it do the same thing. So it's going to move and then we're going to call, we're going to start this other one. So that's how you could branch off a thread from a certain point. So that's how to use them. Maybe I should have done this later, because now I'm going to give a warning about when to use them. So when to use them is when you want to do two actions at the same time. Now you need to be careful, okay, like really careful. Because if your two actions are both a physical or variable change, so like if you try and spin the motor from two different threads, you're going to have a nightmare of a problem. Because the outcome is going to depend on which one ends up happening first, and that's something we don't like called a race condition. So that's when two different things are racing, and the outcome is purely random depending on which one happens to get loaded into the CPU first. Bad plan. Instead, you should be using it when you want to do things like, oh, if I push a button, then I want to kill my current running program so that I can take it back to base without harming itself. That's a valid use case for a thread. Or something along the lines of, if my gyro drifts more than X amount, then I want to disable gyro use in my gyro straights and turn them into just normal straights. And then refuse to leave base until it's been calibrated again. That's a great use for a thread. Kind of a complicated use case, but a great use for it. Yeah, so just be careful when using threads. Think through it. If it's something like thread A sets variable A to be 1, thread B sets variable A to be 2, and they try and run it at the same time, then it's either going to be 1 or 2, and there's no predicting which one. So it's basically just introducing a randomness element, which is not really what you want ever, from personal experience anyway. So the next thing is loop interrupt. So there's kind of two primary things for this. So what we're doing is, so the first one is kind of sketch. Okay. So what it is we have a method called runThread. No variables, nothing, it's just a my block. So when our program starts, we start running the runThread. Okay, and it does whatever we want to do in there. Let's say we've got a loop forever. Okay. And then we've got another control thing that's like when the down button is pressed. So when it's pressed, then what I want to do is I want to stop other stacks, which will kill both of these, and then I want to respawn the run thread. Does that make sense? So you want to do some kind of initialization here that figures out where it should be and jumps to where you actually want to be. And this will make more sense when I make my video explaining how to make a master program in here. Yeah. The other option is always make your loops be repeat until, and then always have at the very base level, or, and then you have a variable that's something called like kill loop. And so you say, you know, if whatever other condition you want your loop to repeat until, or kill loop equals 1, then it kills the loop. So to kill the loop here, you just say set kill loop to 1. Does that's how you do that. That's the safer option. You have less random other threads that you're arbitrarily killing in mass genocide, but it's kind of a hassle. So I'm going to be using the other one. It's up to you and your team which one you feel like going for. It's definitely safer to go this way, but if you know what you're doing and don't want to deal with the hassle, just go for the runnable thread and kill it and respawn it. So that's all for replicating advanced features. We're going to slide over to replicating an Ev3G program. So I'm just going to start and make it real fast. So what we need is we need a couple things. So first, and I'm going to make each step in Ev3G, and then I'm going to slide over and make it in Ev3 Home, and I'm just going to clear up my stuff down here real quick. But then, so we need a Maya block that's CM2 rotations. This is something that is a classic Maya block. If you're using Ev3G and you don't have this, I would highly recommend it. It makes your life a whole bunch easier. So you've got centimeters, and then we output rotations. Okay, and so what we do is we read a number, not a constant. I'll put it back to here. So then, okay. So now we say we're reading a numeric variable. I don't have it yet, but we're going to pretend we do. And this is our wheel circumference. And so then we divide. Pretty straightforward, right? So then now let's make the same thing over here. So we're making a variable wheel circumference, and then we're going to make a variable that's ZZCM2 rotations. Actually, we're going to get rid of the Z just because. So you notice something that I do is I make my variable names pretty long and descriptive just so that it's very obvious what they are. So that there's no confusion. So we want to set the output to be centimeters divided by wheel circumference. And bada boom, bada bing, we have that my block. Okay, so then we come back here, and so now we need to make another my block that's the actual drive CM. Actually, yeah, we're just gonna go drive CM. So then this is how many centimeters, and this is power. And parameter icons for Ev3G are very cool. I'd highly recommend, and if your team's using it, and you're watching this video just for fun or to learn how to use Mindstorms Home, that you establish a standard icon set. So like my team always use this one for centimeters, always use this one for power, just so that when you quickly glance at your my blocks, it's super easy to tell. So what we want to do is we want to see how many rotations is in the centimeters. Then we want to start a loop. Let's loop until logic. And then we want to say in there, we want to, gosh, I've not used Ev3 in a while. So if you notice, if it seems like I'm more comfortable in Ev3 Home, that's a lie. Mindstorms Home, sorry. That's a lie. I've been learning it recently, so it comes slightly more natural to me right now. But in just a bit, I'll be back in the groove of Ev3G. So, and I'm gonna be a brat here actually, because this is the way I actually want to do it. So I'm gonna have to. Okay, so we're coming here and we're saying, so that number of rotations. So we're willing to stop within plus or minus a centimeter. So we say, okay, how many rotations is, well, also, excuse the resolution here. I'm on a Catalina Mac, and so that means I can't actually be running this program. So I am screen sharing it from another Mac that does have it. So it's kind of laggy and the resolution's all over the place. So then we say that centimeter amount minus 1, plus 1 is the max. Whoops. Let's make this easier to read. So that's one of the nice things about Mindstorms Home is some of this nightmare stuff with wires is gone, so it doesn't have to look ugly as heck. Because if you accidentally mess up and make it like this, where it just looks super ugly, then it's kind of a pain. Ag. Okay. So now I want it to just be on, and my bad. This goes here and here. And normally I'd actually apply some kind of change there based on the gyro, but we're just doing a normal drive C and we're not doing a gyro drive. Okay, so now that's done, and that makes sense to most everybody, I would like to think. I'll just walk through it real quick. I might end up cutting me building it, we'll see. So we've got our centimeters and our power. So we say centimeters plus 1 centimeter, how many rotations is that? Centimeters minus 1 centimeter, how many rotations is that? Then we read our rotations and we say, is that within minus 1 plus 1 centimeter? If it is, then kill the loop and stop driving. If it isn't, loop again and keep it on for that power. And you could argue that since I'm not actually changing this power, I can pop it outside the loop, and you'd be right, so I'm going to do that. Okay, so now, replication time. So we've got our centimeters rotations already built. So we're going to come and we're going to start out and make a new my block. Okay, so then in this new my block, I'm going to drag it off a bit. We're we're going to start out and we're going to say, okay, run centimeter rotations. This is where it starts to get interesting because we can't actually run this twice because then we'll overwrite that variable. So instead, we're going to run this directly on that centimeter count. And then we're going to check to make sure it's within plus or minus like 1/10 of a rotation. And that's good, the same thing. So then I want to start us driving. So movement, start moving. And we don't get to pick the power. I'm dumb. So set movement speed to power. Let's just make sure we're on moving B and C. And then we're going to start a loop. So repeat until blank. Or I guess, yeah, repeat until blank. And we're going to say degrees counted. So they don't have rotations, they have degrees. So divided by 360 is how many rotations it's been. So if that rotation amount is less than CM2 rotations output if it's less than it plus 0.1, and this is a cool thing, you can duplicate parts of it just by right clicking, and that will speed up this a lot. And it's got to be greater than it minus 0.1. See how kind of unwieldy and huge that? Wait, what? Shoot. I just deleted it. But that we're gonna undo that one real fast. So that's kind of huge and unwieldy now. But then after the loop, we want to stop moving. So that's our new drive CM. So yeah, thanks for watching. As always, feel free to drop any questions or video ideas in the comments section. More videos on this topic are coming soon. If you want to see upcoming videos, you can see them at our Weebly, link in the description. As Quacktastic topics come, we'll post them here. If you want to see them as soon as they come out, feel free to subscribe. We'd love to see your video ideas in the... what am I doing? We're going to cut this and redo it. It's fine. Thanks for watching. If you have any questions or video ideas, feel free to drop them in the comments section or shoot us an email. We'll be releasing more Quacktastic videos on this topic and other useful skills soon, so stay tuned. Feel free to hit that subscribe button to get notified of the latest videos. If you want to see our roadmap, it's up on our Weebly. The link's down in the description. That'll let you see what state various videos are in and what their scripts are looking like.